Okay, great. It's coming to the last talk today.
Okay, hello everyone. My name is Yimeng from Max4 software team. So first, thank you all for still being here, listen to my presentation. I'm the last talk before the social dinner. Yeah, I'm going to show you our web solution for the SVG-based synoptics at Max4. Hope you enjoy it. So first, maybe some of you are not familiar with SVG. So it's scalable vector graphics. It can be rendered at any size without loss of quality. It's because the graphics is based on the geometric calculation, not the pixels compared to the raster image. So due to this, its great scalability, we create synoptics at Max4 use SVG. So the synoptics we use at Max4 to oversee and control all the beamline systems and also the machines. And it has a user ability to interact with a complex system efficiently because it's very user-friendly and easy to interact. So the solution at Max4, the desktop solution at Max4 for synoptics is Taurus GUI. I will introduce a little bit about the Taurus framework. So it's also no-code and based on Python and PyQt and also widget-oriented. And it's like talk to our PyTango and the behind the system is at our Tango devices. And at Max4, it's running on Rocky Linux and it's deployed with Conda environment. So this is an example of the synoptics shown on Taurus application. So here we can see it's a beamline synoptic, and here we can see that the different sections are marked with the gray box. So you can easily find out which device is not working, and for the beamline scientists, it's very easy to control it. Yeah. So we see some limitations with this desktop application. It's very stable, but it's not less user-friendly for remote access. And also it requires high involvement from the software team because every time they need some update and we need our software engineer to update for them and redeploy for them. And also improve the user autonomy is one of the important things at Max4. So because of this, it's the user autonomy is hindered. So that makes us to think about if we could move the synoptics to web. So we think about moving it to our web interface, Taranta. So Taranta is web interface, and you can easily browse a device from Tango server, and you can interact with them and control the commands and also do some plotting. And you can also quickly develop and change the interactive dashboard with the widgets that allow you to monitor and control the system, even cross the databases, because at Max4, each beamline has its own databases, but for our front-end guys, they can use this cross-database feature to monitor the whole facility. And you can also run experiment on that. So I have seen that at some beamline, they create dashboard for their user experiment. So each experiment has one dashboard. And Taranta is a collaborative project between Max4 and SKA Observatory now. And it's also under the Tango community. So I will briefly introduce Taranta framework here. So it's based on React, and also it's widget-oriented, and the backend is Tango GraphQL. And we are now moving to Ariadne GraphQL. So the communication is based on HTTP and WebSocket, deployed on Kubernetes at Max4. So how did we provide this solution? We provided two ways. One is SVG widget. It's mainly used for the user can upload their SVG file, and you can combine this widget with other widget to create a dynamic dashboard. And another thing is synoptic view, which is mainly for users to interact with their synoptics. So for the SVG widget, it's very easy to use. So you just upload your SVG file and specify some input for the widget, and then you can create name, and it also specify the custom CSS there. Yeah, this is an example of how the widget. So we can see that the SVG widget also in our widgets library. And here I just upload a simple SVG file here and specify the name. And so you can see that you can put SVG widget and other widget together, and you can even create, like, for example, an attribute display, but you can put an SVG file on top of it, so you can create like a different graphics. The second solution is the synoptic view. So it's mainly for, like, you can interact with synoptic SVG synoptics, and you can have an overview of all the connected Tango devices for efficient monitoring. And we also have a thumbnail navigation to enhance gratefully use the scaling feature and have quick access to specific devices. And you can click on each SVG widget, and it will link you to the corresponding device detail. Yeah, I'm going to show you an example. This is LeanNAC synoptics at Max 4. So here we can see that different sections of the LeanNAC part. So if we go close to the short pause facility, here we can see like a different layer of this synoptic, and we can see all the devices like behind. And also you can zoom in from the thumbnail here. If I click run on this one, you can see that all the devices start to communicate, and the different color represents the different status about this device. So you can see that the red one means like the device is in fault. It's not in use, for example. Yeah. I will also cover a little bit about how we handle the SVG files. We use Inkscape at Max 4 to create SVG files. It's open source and free software, very easy to design. And first you create your own SVG file, and then you can go to the object properties. And basically, because we use Tango here, so just in the description, you can specify your model. The model will be the Tango device name. And after this step, it's like almost already done. You can now upload to Taranta and render your synoptics. But we also have some like advanced techniques like for the users to improve on their SVG files. So the first one, you can define custom CSS directly on Inkscape. And also you can like do some custom text format to change the format of your data. And also you can apply like layer-specific rules. This is very useful if you want to hide or highlight some component when it satisfies some condition. Yeah, conclusion on the improvement on this. So this one like improves the remote access. So now without need to access to the specific control beamline to read, to see their synoptics. And also scientists are able to create and apply and test their own synoptics. So in this way, it also facilitates user autonomy, and their feedback and can help us improve these servers furthermore. For the next step, we are now working on the craft widget. So it basically, the idea is like to wrap a dashboard into one widget and make it reused for a class of devices. So I have a prototype at the end about the future work of ours. I hope I can run it. Yes. So this is just a simple example of the synoptic. And currently, if you move it to one component, it will show you the device name, and clicking it will redirect you to the device detail. And for the future, we will add like more interaction with a component. For example, if I want to control this valve, I can open it and close it. And also, we have a new feature with a camera. So by clicking the camera, it will open another camera GUI, which will be used by the craft widget. And in this camera GUI, you can view the basic information about the device, and also you can control start and stop the acquisition from this camera. Yeah. Yeah, I think at last I want to give a great thanks to all the developers that are involved in Taranta project. Yeah, so.
Okay, we can have a few questions.
When editing in Inkscape, do people have like a common icon library they use? Let's say for vacuum symbols?
Yeah, we have Max 4, so all the common widgets there can find, and they can use the common widget for like valves and cameras. Yeah, they can directly use it.
And now the tricky question: do they actually use them, or do they?
Because now we haven't opened this. Like the scientists, they can create their own synoptics. So, but I have seen like some beamlines. They have some very enthusiastic engineers that they already started doing it.
Thanks.
Yeah.
Have you thought about transitioning from the desktop-based synoptics to the web-based? Do you have a way of converting between them?
For now, I don't think we will like totally move to another one. We will keep it both, because when they are at a beamline, the desktop application still would be the best use for them. But this one, it would be like a helpful tool for them to remote access. Yeah. Oh yeah. We can have it's like shared between the two platforms.
Yeah, thanks. Very interesting. When you start allowing users to control valves and other equipment, how do you deal with authorization and authentication?
We have the authorization on Taranta. It's through KickClock, so it's single sign-on authentication. So like everyone has an account at Max4 can log into their own beamlines, but they can only have read access to other beamlines device. Yeah.
Okay, thanks, Yimeng.
Oh, thank you.
Okay. Okay, finally, we'll close the session. Let's thank all the speakers in data reduction session again. And I will give it this.
Where we're going tonight. Yeah, so in case you haven't been to this place, which might be the situation with most of you, we are over here, and you take the tram, the B line. There's only one line, yeah, and this is the terminus. So you just take the B line, and the place where we're going to is called the Couvent Saint-Cécile. Let me just see, Rue d'Olomé. Yeah, okay. So this is the convent. It's a convent. It's an old convent. So sometimes we feel like we're monks working in a monastery. Now we're going to a convent tonight. And the entrance, you must come in from this side over here. There's a garden we're going to go in. So it's the Rue d'Alma. Okay. The stops that you can get off, you can either get off at Saint-Clair or you can get off at Musée, which is just here. So you have two stops. You can get off and then you walk down here and you come in from this side. And then once we're inside, there's a garden. We'll be outside, hopefully, if it doesn't rain. And then we go to there's also a chapel there, which is actually an editor. So they have fantastic books which you can go and look at tonight. Yeah? So this is also part of this, but the entrance, we must use that. And for those people who asked me about cheese, if you enjoyed the cheese last night, the shop that sells the cheese is actually in the street here, Rue Bayard, and they haven't put their name, but I think it's the shop here. It's next to Dauphinois, but one of these shops here. So you walk past it if you walk down here to go in there. So and they'll be open till, I presume, 7:30, as most shops are in France. Yeah. And I think that's all. You should be there by 7:30 this evening. And yeah, if you want to have a drink beforehand, this is a nice area around here. If you want to go for a walk, this is all part of the old part of town. Yeah. And see you all there. Yeah, with your dancing shoes on. No, I'm only joking.